Hi, in this video, let's look at waves, the different types of waves and some of their properties. There are basically two types of waves. One is what we call transverse waves. The other one is longitudinal waves. Transverse waves. Yeah. Let's look at transverse wave first. Let's consider a rope. Let's say this is a rope. The blue line is a rope and I start moving this point. I'm holding it at this point and I start moving this point up and down in a rhythmic fashion. Let's break it down into few initial points on the rope. Let's say I take the point. Let's call this first section as X, the next point on the rope as Y, and the next point as Z. As I move, hold and move, X would move first up, right? So X would be first up. Y would follow X because Y is attached to X, and then Z would follow Y in this fashion. So you see the rope would be in this fashion initially. And when I move it down after time instant, let's call this T1. In the next instance, T2, X comes down and Y start is attached to X, but it wants to come down, but because of the movement upwards, velocity, it goes up, Z stays here. At T3, X comes further down, Y follows X, and Z goes to the top. So as you see here, X is at the top, then Y is at the top, Z is at the top, which means each point here goes to the top and then comes back down up. And then when I pull the rope down in this direction, this was for up, and when I pull the rope down in this direction, the exact opposite happens downward. And that is why when we move a rope up and down in this fashion, we get something like this. The rope starts moving like this in a cyclical fashion. So this is because of this pattern what we discussed just now. And these peak points are called, the peak points are called crests, a crest, and the low points are called trough. So these are crests and these are troughs. This is about a transverse wave. There is another type of wave called a longitudinal wave. Longitudinal wave. Longitudinal wave. Let's take this slinky. It's like a light spring. Let's say I push it at this end with a force. I pat it with my hand, and this starts moving. This section, as first one, the loop starts pushing the next loop, and then it pushes the next loop. And then after a while, what happens is these loops come want to come back to the original position of the slinky, and then they come back. But the push that I gave would keep pushing forward. The other portions, the other loops in the slinky would keep moving, getting compressed. And after the compression, they will relax, or rarefication it's called. So there is a series of compressions and rarefication. So if I pat it just once, you would just see a bunch move forward of a compression till the end. If I keep moving it forward and backward, let's say I hold this point with my hand and I keep moving it forward and backward, the compression would move forward followed by a rarefaction. It will compress, move forward, then the portions which got compressed would relax, rarefy, then the next section would get compressed and rarefy. So instead of crests and troughs, longitudinal waves, we will have compressions and rarefactions. This is what we have in a longitudinal wave. Now the distance between, let's say the distance between a crest and another crest is called the wavelength, or a trough and another trough is called wavelength or lambda. That is the wavelength or lambda. In case of longitudinal waves, you can call it the distance between two compressions, two successive compressions, or two successive rarefaction centers. Because mind you, when the slinky gets compressed, and then let's say this is the normal portion of the slinky, When there is a compression, the center of compression corresponds to the crest. The center of rarefaction can correspond to the trough. So the distance between the two centers of compression or two centers of rarefaction is the lambda for a longitudinal wave. Now, what is frequency? Frequency is, let's say we observe this wave from a point. We are looking at this wave from a point, and then the number of crests that pass this point per second is the frequency. So the faster it moves, the more is the frequency. The number of cycles per second. Let's say I keep looking at this particular point, and then I see five crests passing through this point at in 1 second. Then the frequency is 5 per second, or we call it 5 hertz is the unit of frequency. And time period is represented by T. Time period is inverse of frequency. 1 by frequency is the time period. So naturally the units will be 1 by per second, when it comes to numerator would be seconds would be the unit. So let's say I keep looking at a point in a wave, and the time taken for one wavelength to pass through the point is called the time period. Let's say I start looking at a crest. By the time the next crest comes, what is the time taken? That is the time period. Now, finally, we can come to velocity, which logically we can conclude by saying this is also called the wave equation. Is frequency times lambda. So the unit of frequency is per second, and lambda is meters. So you can say meters per second, which logically also tallies with the unit for velocity, which is meters per second. So this is also called the wave equation. Thank you.